Task number 2, OSI model. This model is one of the two most popular networking models, OSI model and TCP IP model, which will come next in task number 3. Before we start, we should note that the OSI model might initially seem complicated. Don't worry if you encounter encryptic acronyms. As we provide examples of the OSI model layers, we assure you that by the time we finish this module, this task will feel like a piece of cake. What if I don't like that cake? I don't know, jokes. The OSI, Open Systems Interconnection model, is a conceptual model developed by the International Organization for Standardization, ISO, that describes how communications should occur in a computer network. In other words, the OSI model defines a framework for computer network communications. Although this model is theoretical, it is vital to learn and understand as it helps grasp networking concepts on a deeper level. The OSI model is composed of 7 layers, going from the 7. I see they switch the. This is the usual one, and it goes from the bottom to the top. Physical layer number 1, data link layer number 2, network layer number 3, transport layer, session layer, presentation layer, and application layer. So basically, yes, this OSI model and or TCP/IP model, they are just information. So that information, visual information, and theoretical information, so you understand how a network works. So from the moment you click on a website, just to understand what is going on, to understand how packets travel, how routers work, how the traffic is basically moved, requested, sent and requested, and then how the server responds. Basically just, it's a very, very good framework in order to understand the basic concepts of networking. The numbering starts with the physical layer being layer number 1, while the top layer, the application layer, is layer number 7. To help you understand, to help you remember the layers from the bottom to the top, you can use a mnemonic such as "please do not throw spinach pizza away." These mnemonics are just random names. You can just throw away random words and you can just form also a mnemonic for yourself. You can check the internet for other easy to remember acronyms. If this helps you memorize them. Remembering the OSI model layers with their layer number is important, otherwise you will struggle to understand terms such as layer 3 switch or layer 7 firewall. I mean, to be honest, mnemonics, I don't know if you need mnemonics for this one, because they are pretty logical. From the physical layer, you enter in the data link. From the data link, you go network. So they go like this in a logical manner. As we'll start to go and read more about them, you will understand why I say so. So if you read more about them and you just practice a bit, it will be very easy to remember. Yeah, mnemonics are basically just, I don't know. To me, mnemonics are just random words added together from the person that created the article. Layer 1, the physical layer. The physical layer, also referred to as layer 1, deals with the physical connection between devices. This includes the medium, which is just a wire, is the physical wire. That's the medium, but it's a fancy word. Such as a wire, and the definition of the binary digits 0 and 1. Data transmission can be via an electrical, optical, or wireless signal. Consequently, we need data cables or antennas, depending on our physical medium. In addition to Ethernet cable shown in the illustration below, an optical fiber cable examples of the physical layer medium include the Wi-Fi radio bands, the 2.4 gigahertz band and 5 gigahertz band, and the 6 gigahertz band. Yeah, so basically layer 1, the physical layer, is basically just the cables, just to be easily understood. And in the cables, we use electricity, which is basically the binary digits transformed digitally in 0 and 1. Layer number 2, data link layer, the physical layer, defines a medium to transport our signal. The data link layer, that is number 2 layer, represents the protocol that enables data transfer between nodes on the same network segment. Let's put it in a simpler terms. The data link layer describes an agreement between the different systems on the same network segment on how to communicate. A network segment refers to a group of network devices using a shared medium or channel for information transfer. For example, consider a company office with 10 computers connected to a network switch. That's a network segment. Examples of layer 2 includes Ethernet, that is A802.3, and Wi-Fi, which is A02.11. Ethernet and Wi-Fi addresses are 6 bytes. Their address is called the MAC address, where MAC stands for Media Access Control. They are usually expressed in hexadecimal format with a colon separating each hexadecimal digit, which is 1 byte. The 3 leftmost bytes identify the vendor. And these 2 is the actually the other way around. These 3 are the vendor, and this is the unique address of the network interface. This entire thing is unique for each device. So the first 3 segments or segment of 2 symbols are the vendor, the letter and the number. Vendor who built the network interface. For example, Intel has this code. And then to the right of it, we have a unique address. So the data in this link is coming in the medium from physical layer 1, and it's coming in the binary format in 0 and 1. That's the data link layer. We expect to see 2 MAC addresses in each frame. In real network communications over Ethernet or Wi-Fi, the packet is in the screenshot below shows the destination data link address, highlighted in yellow. We see it over here in bytes. The source data link address, which is highlighted in blue. And then the remaining bit shown the data being sent. Here in the displayed picture, this is just extra information. I think we'll jump into it later. It uses Shark to intercept this packet. And then it shows you the destination in yellow, and then the source in blue. You can see it over here also with the MAC address. Layer number 3, the network layer, the data link layer, focuses on sending data between 2 nodes on the same network segment, as I said already. So we have an office building with computers. That's the network segment. And then we have the nodes on that network, which are the computers using that network. And then they share data between them, basically. The network layer, that is layer 3, is concerned with sending data between different networks. So here, from the network segment, the office building, we are expanding our sending of the information. We want to hit, for instance, the office from, I don't know, Spain, and we live in Italy. In more technical terms, the network layer handles logical addressing and routing, that is finding a path to transfer the network packets between the diverse networks. In the data link layer, we gave an example of one company office with 10 computers, where the data link layer is responsible for providing a connection between them. Let's say this company has multiple offices distributed across various cities, countries, or even continents. The network layer is responsible for connecting the different offices together. The network below shows the concepts A and B Computers A and B are connected, although on the different networks. You can also notice two paths connecting the two computers. The network layer will route the network packets through the path it deems better. Yeah, so basically computer A and computer B, and here we see the routers, the how the data travels, or how the data can travel, displayed by the green. Example of the network layer includes the IP protocol, Internet Control Message Protocol, basically the IP, ICMP, and Virtual Private Network VPN. Protocols such as IPsec and SSL TLS VPN. Layer number 4, the transport one. Layer number 4, the transport layer enables end-to-end communication between running applications on different hosts. Your web browser is connected to the TryHackMe web server over the transport layer, which can support various functions like flow control, segmentation, and error correction. Examples of layer 4 are transmission control protocol, TCP, and user datagram protocol, UDP. These two are basically the most common transport protocols. Layer number 5, session layer. The session layer is responsible for establishing, maintaining, and synchronizing communication between applications running on different hosts. Establishing a session means initiating communication between applications and negotiating the necessary parameters for the session. Data synchronization ensures that data is transmitted in the correct order and provides mechanisms for recovery in case of transmission failures. Examples of session layer are network file systems, NFS, and remote procedure call, RPC. Layer number 6, presentation layer. The presentation layer ensures data is delivered in a form the application layer can understand. Layer number 6 handles data encoding, compression, and encryption. An example of encoding is the character encoding such as ASCII or Unicode. Various standards are used at the presentation layer. Consider the scenario where we want to send an image via an email. First, we use the JPEG, GIFs, and PNGs to save our image. Furthermore, although hidden from the user by the email client, we use MIME, multipurpose internet mail extension, to attach the file to our email. MIME encodes a binary file using 7-bit ASCII characters. This is basically the MIME, 7-bit ASCII characters. I think we'll develop more on these later. Layer number 7, application layer. The application layer provides network services directly to end user applications. Your web browser, for instance, uses HTTP protocol to request a file, submit a form, or upload the file. The application layer is the top layer, and you might have encountered many of its protocols, such as you use different applications. For example, protocols, examples of layers number 7 protocols are HTTP, FTP, DNS, POP3, email, SMTP, and IMAP. Don't worry if you are not familiar with all of them. Summary: reading about the ISO OSI model for the first time can be intimidating. However, it becomes easier as you progress in your study of networking protocols. To help your study, we summarize the ISO OSI models in the table below. So from the layer 1, the physical layer, physical data transmission, we have the protocols. A lot of protocols when we talk about networking. We have the electrical, optical, and wireless signals. Layer number 2, data link layer, is the reliable data transfer between adjacent nodes. We have Ethernet and Wi-Fi. Layer number 3, network layer, is the logical addressing and routing between networks, where we have the protocols of IP, ICMP, and IPsec. Layer number 4, transport layer, end-to-end communication and data segmentation, where you have UDP and TCP. Layer number 5, session layer, establishing, maintaining, and synchronizing sessions, NFC, RPC. Presentation layer, data encoding, encryption, and compression, Unicode, MIME, JPEG, PNG, and MPEG. And layer number 7, application, providing services and interfaces to application, HTTP, FTP, DNS, POP3, SMTP, and IMAP. Answer the questions below. Which layer is responsible for end-to-end communication between running devices, running applications? Layer number 4, the transport layer, end-to-end communication and data segmentation, where we have UDP and TCP. So we have layer number 4. Which layer is responsible for routing packets to the proper network? Logical addressing and routing between networks, the network layer number 3. In the OSI model, which layer is responsible for encoding the application data? The encoding data and encryption and compression is presentation layer number 6. Which layer is responsible for transferring data between hosts on the same network segment? That's if you remember from the above in the network segmentation, data link number 2. Basically the layer 2 data link layer, if we go a bit up here and we see the network segment, if you remember consider a company office within 10 computers connected to a network switch. That's a network segment.